The decline of the Y chromosome. What it means for men and humanity. Introduction. The Y chromosome, which determines male biological characteristics, is facing an existential threat. Over time, the Y chromosome has gradually lost a large portion of its genetic material, which has led scientists to worry about its future. In this lecture, we will explore why the Y chromosome is in danger, what factors contribute to its decline, and the implications this has for human biology and reproduction. The role of the Y chromosome. The Y chromosome is one of the two sex chromosomes in humans, the other being the X chromosome. Its primary role is to determine male sex characteristics. Men inherit one Y chromosome from their father and one X chromosome from their mother, while women inherit two X chromosomes. The key gene on the Y chromosome responsible for male development is the SRY, sex-determining region Y, gene, which triggers the formation of testes in the early stages of fetal development, leading to the production of male hormones like testosterone. The shrinking of the Y chromosome. Historically, the Y chromosome was much larger and had many more genes. However, over the course of human evolution, it has shrunk significantly. Today, it carries only about 50 to 200 functional genes, whereas the X chromosome contains over 1,000 genes. This reduction is alarming to researchers for several reasons. 1. Evolutionary erosion. Over millions of years, the Y chromosome has been losing genetic material. Unlike the X chromosome, which can repair itself through recombination with its pair, the Y chromosome has no matching pair to exchange genetic information, making it more susceptible to mutations and deletions. 2. Mutation accumulation. Because the Y chromosome doesn't undergo recombination like other chromosomes, any damage to its genes isn't repaired. This makes it vulnerable to accumulating harmful mutations over time, which could lead to the further loss of essential genes. 3. Reduced genetic diversity. Due to its unique inheritance pattern, passed only from father to son, the Y chromosome lacks the genetic variation seen in other chromosomes. This lack of diversity increases its vulnerability to detrimental genetic changes. Why is the Y chromosome in danger? 1. Loss of genes. Over the past 300 million years, the Y chromosome has undergone rapid gene loss. It once had thousands of genes, but now only about 3% of its original genes remain. As the Y chromosome continues to degrade, there is concern that it could eventually disappear. 2. Fewer repair mechanisms. Chromosomes are typically able to repair damage through a process called recombination, where two matching chromosomes exchange genetic material. However, the Y chromosome doesn't have a partner to recombine with, which limits its ability to repair itself. 3. Genetic drift. The small size of the Y chromosome means that random changes and mutations in the Y chromosome can have a significant impact over time. This leads to a decrease in the number of functional genes on the Y chromosome. 4. Natural selection. While natural selection can eliminate harmful mutations, it doesn't always prevent the loss of genes that may not have an immediate function. This means that over time, the Y chromosome can lose essential genes that don't directly affect reproductive success but are still crucial for long-term survival. Potential implications of Y chromosome decline. 1. Male infertility. One of the most direct consequences of the decline of the Y chromosome is the increasing rates of male infertility. Many of the genes found on the Y chromosome are linked to sperm production. As these genes continue to degrade or mutate, it could result in reduced fertility or sterility in men. 2. Changes in male development. If the Y chromosome continues to lose its genetic material, it could lead to defects in male development. The SRY gene, which is essential for the development of male characteristics, could be affected. This could lead to conditions like Swyer syndrome, where individuals with an XY chromosome pattern develop as females due to a defective SRY gene. 3. The end of males. One of the most controversial ideas is the possibility that men, as we know them, could disappear if the Y chromosome were to vanish completely. Some scientists predict that this could happen in the distant future, though others argue that new genetic mechanisms or evolutionary solutions will arise to compensate for the loss of the Y chromosome. Evolutionary workarounds despite the alarming predictions. There are reasons to believe that the loss of the Y chromosome may not spell the end of males or male characteristics. 1. Other species examples. Some species have already lost their Y chromosomes. For instance, certain rodents have found ways to reproduce without a Y chromosome, using other parts of their genome to compensate for its loss. This suggests that evolution could find alternative ways to preserve male development. 2. Human adaptation. Humans may also find alternative evolutionary pathways. Some scientists hypothesize that other parts of the human genome may eventually take over the functions of the Y chromosome, ensuring the continuation of male development and reproduction. 3. Genetic engineering. Advances in genetic engineering could potentially offer solutions. Scientists may be able to identify and repair mutations on the Y chromosome, preventing its further decline. Alternatively, gene editing technologies like CRISPR could offer ways to replace defective genes or even create synthetic Y chromosomes in the future. Conclusion: the Y chromosome is indeed in danger. But the potential disappearance of the chromosome is not an immediate threat. The decline of the Y chromosome raises important questions about male health, reproduction, and the future of human evolution. While the loss of genes from the Y chromosome is a concern, there is also hope that science and evolution will find ways to adapt. Understanding the risks involved offers an opportunity to explore potential solutions and highlights the ongoing importance of genetic research in safeguarding human reproduction and diversity. The decline of the Y chromosome.